Alright, we've got example 3 from the notes on the Hopitals rule. So in this situation we're going to have an infinity over an infinity, which means that L'Hopital's rule does apply. So one notation is to do an equal sign and to have LH over your equal sign for L'Hopital's rule. So now I've got my limit as x approaches negative infinity. So if I take the derivative of the top, I've got 2x. And if I take the derivative of the bottom, then I'm going to have a negative e to the negative x. Based on the instructions here, we're going to do L'Hopital's more than once, because if you evaluate the limit again, now I'm going to have a negative infinity over negative infinity, which is still an indeterminate form. So I can go ahead and take another derivative. And now if I evaluate to negative infinity, this is going to be 2 over e to the infinity, and as the denominator gets very large, this is going to approach 0. Alright, example 2. So in this situation, we do not have a fraction, so you'd have to do a rewrite. So now if I evaluate as my limit goes to positive infinity, my numerator would go to infinity and my denominator would go to infinity, which is L'Hopital's rule. So I can take my derivative of my numerator and my denominator separately. And same, we need to have a ratio of a function over a function to be L'Hopital's rule. So I'm going to keep it in this same form. And if I take my limit going to infinity, this would be a 0 over an infinity. So 0 over infinity, you don't know who's going to win the race. So we'll try it again. So that would be a negative 1/2 power. So if I bring the negative 1/2 power, this is going to be a negative 1/4 power. And then I've got to subtract 1, so that would be x to the 3/2 all over e to the x. And this is still my limit as x goes to infinity. So this is just looking crazier and crazier.